Alright, ladies and gentlemen, we're going to solve some trig equations, and some of these may have some properties in them, and we're going to have to handle that when we get to them. But the first couple questions here, these says find all intersections, points of intersections for the two given functions. So if I give you a function f and a function g, and I want you to find where they intersect, you just set them equal to each other, and then we're going to solve. So this will say 3 cosine x plus 1 equals cosine x minus 1. So if we're going to solve this, it's probably a good idea to get everything on one side first. Let's get all the cosines on one side. So this is 1 cosine x, and over here we have 3 cosine x's. So if I subtract cosine x, 3 cosine x minus 1 cosine x is 2 cosine x. And if you add 1, you're going to have plus 2 equals 0. If you have everything on one side, sometimes you can just solve this by factoring, and that's a good plan here. Once you have everything on one side, let's see what we can bring out. I can bring out a 2. I have cosine of x plus 1 equals 0. So what I really want to know is, when does this factor equal 0? When does cosine x plus 1 equal 0? Which is really like saying, when does cosine x equal negative 1? So cosine x equals negative 1. Remember, cosine is your x value. That happens over here. So cosine x equals negative 1 at pi. X equals pi, and if it says all solutions, you can say pi plus 2 pi n. So where do they intersect? They intersect at pi the first time, and then they're going to intersect every 2 pi after that. So the first one, nothing too fancy. Second one is the same game. We're going to set them equal. The sine of 2x equals 2 times the sine of 2x plus 1. So again, these are like terms, the sine of 2x and 2 sine of 2x. So if I subtract the sine of 2x on both sides, 2 sine of 2x minus 1 sine of 2x is 1 sine of 2x. So I have 0 equals the sine of 2x plus 1. Okay, so let's get the sine of 2x by itself. Negative 1 equals the sine of 2x. Now, this is where the problem is a little different than other ones that we've done. So what I'm going to do is just kind of think about what this is saying. This is saying that the sine of something is negative 1. So if I ask you the question, when is the sine of theta negative 1? Well, theta is negative 1 right here. Sine is negative 1 right here. That's at 3 pi over 2. If you take the sine of 3 pi over 2, you get negative 1. So theta would be 3 pi over 2. If I could say the sine of theta, I'd be fine. But the difference in this problem is, I'm not actually asking what the sine of theta is. This is the angle. I want to know what 2x is. 2x is 3 pi over 2 plus 2 pi n. So if I want to get all the coterminal ones, you say, well, this is at 3 pi over 2. This is where sine is negative 1. So sine is negative 1 at 3 pi over 2, and then every 2 pi after that. So I've got a solution here if this said the sine of theta equals negative 1. But since it's not actually theta, it's 2x, you need to say, okay, well, 2x is 3 pi over 2 plus 2 pi n. And if I want to solve for x, then I need to divide by 2, which is the same as multiplying by 1/2. So x equals 3 pi over, not 2 anymore, 3 pi over 4 plus 2 divided by 2 is 1 whole pi n. So 3 pi over 4 plus pi n, those are your solutions now. So what you need to do is, if you ever see you're taking the sine of something that's not an angle, a single thing, then just do like a little substitution and say, if that was an angle, when would sine be what I'm looking for, whatever trig function, when would it be what I need? And then you can go back and say, oh, well, it's actually 2x, and then you're going to have to change your solutions a little bit. So here I had to divide everything by 2, so 3 pi over 4 plus pi n. Let's try another one. This one's actually pretty easy. The tangent of x equals radical 3. Well, that's one we should just have memorized. You should know that the tangent of x is radical 3 when you have a 60-degree reference angle. So 60-degree reference angle looks like that. That happens at over 3, and then again at 4 pi over 3, which I'll just say plus pi n. So that's the solutions for that one. So we didn't need to do a substitution there. Let's try another one. This is probably the hardest one. So here, we're going to use a property, and what you have to do is, you're going to need the formulas. Well, I have this one right in front of me. This says cosine, cosine minus sine, sine. Cosine, cosine minus sine, sine. So this is really a cosine sum problem. So I'm going to rewrite this as the condensed version, which would be x plus 3x, because those are my angles. So what I'm really saying is the cosine of 4x equals 0. So this is like that one we just did. I want to know when cosine is 0. So I'm going to just think, I don't know about all that 4x stuff. What if I just said the cosine of theta? What would theta be? Where is cosine 0? Cosine is 0 right here and right here, so that's pi over 2 plus pi n. That's when cosine is 0. So if cosine is 0 at pi over 2 plus pi n, great. I know where cosine is 0, but I don't know when 4x is going to equal theta. So I'll just set those two things equal now and say, okay, that's not really what I'm finding. 4x is this angle. And then I can divide everything by 4. So if I divide everything by 4, you're going to have pi over 8 plus pi over 4n. Which is great, those are the solutions, but this problem has an extra layer of kind of trickiness to it, and that is that it wants just the interval 0 to 2 pi. And this is where you're going to think, well, it's only these two, right? No, there's actually going to be a total of 8 solutions. Since the original, this has 2 solutions, if I put a 4x in there, now I'm going to have a total of 8 solutions between 0 and 2 pi. And the way you find them is you just kind of go through this until you get all the ones that are less than 2 pi. So pi over 8 is definitely the first one. Then I'm going to add pi over 4 to pi over 8 and see what I get. Pi over 4 is 2 pi over 8, so I'm going to add 2 pi over 8. So 1 pi over 8 plus 2 pi over 8 is 3 pi over 8, 5 pi over 8, 7 pi over 8, 9 pi over 8, 11 pi over 8, 13, and 15. Now, you're like, well, how do I know to stop? When do I stop? You stop when you get to 2 pi. If I added another one, I'd be at 17 pi over 8, and 17 pi over 8 is bigger than 2 pi. So since 17 pi over 8 is greater than 2 pi, we're not going to include it. We're going to stop. These are all the ones that are between 0 and 2 pi. And like I was saying before, if your original equation, this guy has 2 solutions, then you should have 8. So 1, 2, 3, 4, 5, 6, 7, 8. There they are. So we used a cosine addition property, and then we figured out where cosine is 0, ignored the 4x, and just said that's theta. When is cosine 0? Cosine is 0 at pi over 2 plus pi n. And then I went back and said, well, really, since that's not what I was looking for, I got to make that a 4x, divide everything by 4, and then start counting until you get to a number that's bigger than 2 pi, and just say, that's it, I'm done. Let's do one more. So here's another one where it says cosine, cosine plus sine, sine. So cosine, cosine plus sine, sine. This is a cosine difference problem. X minus 2x. So what I'm really saying is that the cosine of negative x equals 1/2. Now this is a property that we talked about in functions, but since cosine is an even function, you can actually ignore that. And this is something that you probably don't need to have memorized. We'd have to go over it a little bit more, but I'm just going to tell you for this problem that cosine of negative x is the same as cosine of x. I'll leave that for you to explore if you want to know why. If cosine of x is 1/2, well, that's actually pretty easy. When is cosine 1/2? Cosine is 1/2 when we've got a 60-degree reference angle in the first quadrant, or cosine is also positive in the fourth quadrant. So where does this happen? At pi over 3 and at 5 pi over 3. And since it's just between 0 and 2 pi, I don't need to worry anything about the plus 2 pi n stuff. So that's my answer. So now, go ahead and try these practice problems. However, just cross out 60 and number 7. We're not going to do those square both sides problems. There's extraneous solutions. You can try them if you want. They're interesting problems, but there's a lot more going on. So you need to be able to do example 6, and then number 63, and number 64, and eventually we're going to have a quiz over this. So good luck, and check the answers. They're on Schoology.